Let's take a look at the examples for chapter 3, starting with true and false questions. The median of a data set is found by adding all the values in the data set and then dividing the results by the number of observations. This is false. Outliers are extreme values above or below the mean that require special consideration. This is true. You always have to know if there are outliers in your data set. There can be more than one mode in a data set. That is also true. Some data sets may not have a mode. That is correct. The standard deviation of a data set can never be negative. That is true. Using n minus 1 in the denominator for the sample variance is a much better estimate of the true population variance when compared to dividing by n. This is true. When comparing two samples, the smaller coefficient of variation indicates more consistency or less variability within the sample of the population. This is also true. Let's take a look at the multiple choice questions. What is the value in the data set for which half of the observations are higher and half of the observations are lower? This would be the median. The what is found by determining the index point I, 0.5 times n, where n is the number of data points. This would be your median. The what is the value that appears most often in the data set? This would be the mode. Which of the following statements is true for a right skew distribution? That would mean that the mean is greater than the median. The what can be found by subtracting the lowest value from the highest value in the data set. That would be the range. A disadvantage of using the range as a measurement of variability is that it is highly influenced by outliers, as we mentioned before. What is the most common and most important measure of variability in the field of statistics? This would be the standard deviation. We use it in multiple other measurements as well. What measures a distribution's standard deviation in terms of its percentage to the mean? This would be the coefficient variation. The average SAT score for incoming freshmen at a particular college is 535 with a standard deviation of 60. The coefficient of variation for SAT scores at this school is what? So we have the average, which is 535. We have the standard deviation, which is 60. So we will do 60 over 535 times 100%. This should be 11.2%. What identifies the number of standard deviations a particular value is from the mean of the distribution. This would be the definition of the z-score. There are currently 7 statistics classes being taught this semester at a specific college. The following data represents the number of students in each class. Calculate the population mean. The population mean is mu. We take the sum of all the entries over the population size. N is equal to 7. We add them all. We divide, so you would do 20 plus 25 plus 28 over 7, and this should be 25. So the average will be 25. The following data represents the amount of money that the last 9 customers sent at the checkout of a local Costco. Calculate the median of the sample. Now, as soon as we want to calculate the median, we have to place the data in order. So first off, we place the data in order: 78, 106, 118, 120, 169, 183, 193, 225, 256. We have n equal to 9, an odd number. Therefore, we take the value in the middle. The value in the middle is 169. So the median will be equal to 169. There are currently 7 statistics classes taught this semester at a specific college. The following data represents the number of students in each class. Determine the mode for this data set. If we take a look, there's not a single entry that occurs more than once. Therefore, there is no mode for this specific data set. So this is no mode. Now, for the same example, we want to calculate the variance. For the same example, we want to calculate the variance. So if we were to do this, I would just give you the solution right here. So for this data set, we have all the entries. To find the sample variance, we have to find the sum of all the entries. So we simply add each one. If we add them all, we get 175. The next step is to square each one, and then we add them. This will give us the sum of the squared entries. And the next step will be to go to the formula and plug in the numbers that we found. So S squared, the variance, is equal to the sum of the squared entries. The sum of the squared entries is 4,541 minus the sum of the entries is 175 squared. Do not forget to square at this point whatever you found for the sum of the entries, over the number of the sample size, which is 7, and all of that over 7 minus 1. If we do that, then variance should be 27.667. Now, a soda producer conducts a taste test for 2 different cola formulations. Each individual rates one of the formulations on a scale of 1 to 20. The taste test data is shown below. So this is what we have. Which formulation provides the most consistent taste test result? So let's see what we have here. We would have to find the coefficient of variation to do so. So let's start with the first group, cola 1, the second group, cola 2. So we will have for the first cola, this is our data set. We find the average is 11.4, we add them, we divide by 7, and then we need to find the standard deviation in order to plug it in the coefficient of variation formula. However, in order to find the standard deviation, we first have to find the variance. How do we find the variance? We add all the entries, we find the summation of the square entries, we plug it in the formula, and then whatever we get, we find the square root of that. So the standard deviation for the first set of data is 2.637. The average is 11.4. So the coefficient of variation is S over X bar times 100%. S is 2.637. X bar is 11.4 times 100%, 23.13%. Again, this is the coefficient of variation for the first set of COLAs. We repeat the same process for the second step, which means we add all the entries, we divide by 7, the average is 12.6. We find the standard deviation by taking the summation of all the entries, the summation of all the square entries, plug it in the formula for the variance, and then taking the square root for that to find the standard deviation. If we calculate the coefficient of variation for the second step, the second set of COLAs, this would be 42.21%. If we were to compare the two coefficient of variations, we would say that the first group had a smaller variability, a smaller coefficient of variation. Not by much, but enough to determine that it's more consistent. So the first one was 23.13, the second one was 42.21. Now, suppose the employee's share of annual healthcare cost for 2012 is thought to be bell-shaped and symmetric, with the mean of 2,796 and the standard deviation of 426. Based on this information, what interval of annual healthcare cost would we expect approximately 95% of the employees to fall within? So we have a bell-shaped distribution, symmetric. I'm looking for 95%. Therefore, we know we will be using the empirical rule. The empirical rule will be mu plus minus 2 standard deviations because I have a 95%. So based on that, mu is 2,796 plus minus 2 times 426. So we will do, for the lower limit, 2,796 minus 2 times 426. For the upper limit, 2,796 plus 2 times 426. So this would be 1,901 to 3,616. Again, if I was looking for a different percentage, the number of standard deviations would change. Now, problem number 7. For problem number 7, Candy Kitchen sells chocolate nonpareils in 8-ounce containers. Because the candy pieces are not uniform, the weight of each individual container varies significantly. A random sample of 9 containers was weighted on a precision scale, and the results are shown below. So this is the data that we have. Determine the interquartile range for this sample. Are there any outliers in this data set? So this is our data set. We have to determine Q1 and Q3. First thing we need to do is place the data in order. So we will have 7.86, 7.87, 7.99, 8.03, 8.06, 8.09, 8.2, and 8.43. I'm looking for Q1. I have to calculate index I. I will be equal to 25 over 100 times 9, because 9 are the entries that I have. This will be 2.25, which is rounded up to 3. and I take the third ranked observation, which is 7.99. Q3 I will be equal to 75 over 100 times 9. This will be equal to 6.75. 6.75 will be rounded up to 7, and I take the 7th ranked observation, which makes this to be 8.09. Now, based on these two, IQR will be equal to 6.75 8.09. Let me write it again. 8.09 minus 7.99. So this would be equal to 0.10. So the interquartile range will be equal to 0.1. Now, for the upper limits and for the outliers, the upper limit and the lower limit, let me just bring the solution here, and then I will use another for 8. We will have to, for the lower limit, we have 7.99 minus 1.5 times 0.1, which would be 7.84. And for the upper limit, we would do 8.09 plus 1.5 times 0.1, which would be 8.24. The last observation is greater than the upper limit, so the container that weighs 8.43 would be considered an outlier based on our calculations here. Now, for the following data, for problem number 8, represents the amount of time in minutes that a random sample of Parisians spent eating lunch at a particular cafe. We want to determine a 5-number summary and create a box and whisker plot. I have the solution with a bit more space here for this question. We, of course, the 5-number summary consists of minimum, Q1, Q2, Q3, and maximum entry. We place the data in order. Minimum is 17, maximum is 39. We have to calculate P25, P50, P75. For Q1, the index is 2.5. We round up to 3. We take the third ranked observation, which is 20. For Q2, index I is 5, which means we have to take the average of this position plus 1. 5th and 6th observation. 5th observation is 23, 6th observation is 24, 23 plus 24 divided by 2, this would be 23.5. So the 50th percentile, Q2, is 23.5. For Q3, I is equal to, index I is equal to 7.5, we round up to 8, we take the 8th ranked observation, which is equal to 27. Given the 5-number summary that we have found, our box and whisker plot would look something like this, and this would be over here, your Q2, right here. Minimum, Q1, Q2, Q3, maximum. And this concludes the examples for chapter 3.